Prototyping Exoskeleton Interaction for Game-Based Rehabilitation. Authors are Barnabás Homola, Isabella Sheldon, Stela, Milton Mariani, and Paulin Hansen. A major challenge many countries are facing is an aging population correlating to an increasing number of people who suffer stroke. Every year, more than 14 million people around the world will suffer stroke. According to the World Health Organization, there are over 80 million living people who have experienced a stroke attack. The most glaring statistic is that 1 out of every 4 people will suffer stroke in their lifetime. As the population continues to age and live longer, there is an increase in desire to age in place. This requires patients to conduct their rehabilitation at home. However, most rehabilitation devices are large, non-portable, and not super user-friendly, not to mention typically very expensive, keeping out of the reach of most of the population. Therefore, at-home rehabilitation devices need to fulfill 4 characteristics: low cost to make it highly available, flexible to be adapted to the different needs of each patient, safe, as patients are likely to conduct rehabilitation without a therapist present, and lastly, it must be easy and intuitive to use. So what do we do? How about turning stroke survivors into real-life Ironmen? How do we get there? To pursue this potential, we utilize a locally designed toy that is world famous for fun and creativity to build things. LEGO Technic serves as the core to building an exoskeleton prototyping toolkit that has allowed us to explore interaction design concepts. Research into new interfaces begins with trying to understand how prototype exoskeletons can be used as an interface for serious games. On the left, a flyby video showcasing a close-up view of an early version of the exoskeleton toolkit design. On the right is an image from Case Study 2 extension, in which researchers combine exoskeleton with an eye tracker built into a VR headset to activate motors on the exoskeleton to assist with rehabilitation exercises. Serious games have become an alternative to conventional therapy, as games can elicit motivation, maintain higher levels of engagement, and generally more entertaining. Case Study 1 uses the exoskeleton as a control interface for children with cerebral palsy to play a simple game by flexing or extending the leg to move the avatar. Case Study 2 presents exploring the exoskeleton as an interface to provide feedback. First clip shows researchers sending signals from a computer to the exoskeleton's motors. In the second clip, a researcher is playing a game that explores visual modality, correlation to auditory and haptic motor feedback, effect on body ownership. Recently, our researchers have connected 2 exoskeletons in a primary and secondary control arrangement, where the primary serves as lead and sends any motor movements to the secondary exoskeleton to replicate, as seen in the image on the left. This has implications for remote rehabilitation as guidance or controlling the exercise, but also as a venue for empathy. If a patient wears the primary, and the therapist or other stakeholders wear the secondary, they can experience from a first-person perspective what the patient has done during rehabilitation. The image on the right shows testing of the exoskeleton with other technologies such as the HoloLens 2, an augmented reality headset, which utilizes hand tracking as the main method of input. However, researchers discovered the bulkiness of the exoskeleton caused the camera vision issues with the hand tracking. In the future, we will investigate how to integrate multiple sensors such as EMG, GSR, and fuse the data from other sensors such as eye tracking to provide a more robust control interface for serious games. This will provide adaptability of an exoskeleton to different disabilities afflicting people with stroke and other neurological diseases.